Hello students, welcome to Akshara 8 Foundation. So myself I am Shiv Shankar, I am a physics teacher. Today we are going to do their exercise problems. In the last class in Newton laws of motion, first synopsis 1 up to concept based questions we have completed. So today we are going to see their exercise problems. So in that the first problem is given there, exercise 1 there. In practice sheet 1, exercise 1 there. Okay. So when a fan is switches off, it continues to motion due to, okay, that is inertia of motion. Inertia of motion. So exercise 1. So first problem there. So first option is option inertia of motion. Inertia of motion. So first answer is inertia of motion there. First solution. And now see the second one. Okay, second one. So second one is given here. Passengers in the bus falls forward. The bus stops suddenly. So passengers in a bus stop suddenly. They will be fall forward when the bus stops suddenly there. Okay. So that is, it is inertia of rest. Second option, inertia of the passengers fall forward. So that is inertia of motion. Inertia of motion. Inertia of motion. So third one you see here. Third one. An athlete runs some distance before taking a long jump. That is due to increase the inertia, to get the adequate amount of inertia so that he can change the direction from motion to change in direction there. Okay. So that is the reason why a person is he will be runs before taking the long jump. Okay. So that is because to get the enough inertia to overcome that inertia of direction there. Okay. So then it is to get inertia of direction. So here we can write the option 4. So third one is option no. Inertia of direction. Third one we can write there. Inertia of direction. Inertia of, to get enough inertia. To get, running gives the himself large inertia. So option 4. Option 4, large inertia. Large inertia. Large inertia. So now fourth one is either here. When a wet dog shakes, so that is due to the inertia. When a wet dog shakes her body, then all the water will be sprinkles out from the dog. So that is because of the inertia of rest. So inertia of rest there. Inertia of rest. And fifth one is either here. The passengers in the bus fall backward when the bus starts suddenly there. So they will be fall backward. That is because of the inertia of rest. Same answer for fifth one also. Same answer. Inertia of rest. That is inertia of rest. If a stone is tied to a straight string, if a stone tied to a string there and whirled in the direction of motion, at any instant it is left the thread there, then it will be moving in a tangential direction. That is due to the, so in which direction it will move there? Along the tangential direction. So here the sixth one is tangential direction there. Tangential direction. So it will be move the tangential direction. That is the sixth one. And seventh answer here. According to the Newton's law, first law of motion, unless some external force act on a body, it will continue in its state of rest or uniform motion. So state of rest or uniform motion. State of rest or uniform motion. Uniform motion. State of rest or uniform motion. Okay. So now eighth one. The tendency of a body to maintain its direction of motion is called there. So that is inertia of direction. So eighth one is inertia of direction. Inertia of direction. Inertia of direction. And ninth one, the water drops striking to a cycle tire are found to be leaving tangentially because of, that is also inertia of direction. So this is also, ninth one is also inertia of direction. 10th one is there. When a knife edge is sharpened by placing it on a rotating iron disc, the spars move tangentially to the disc, that is due to the inertia of direction. So here the options are given there, inertia of motion, inertia of direction. So here 10th one is also inertia of direction only. 10th one is also inertia of direction. So these are the options, answers for up to 10th there. Now 11th one we will see there. 11th one, see the 11th question here. 11th one. So 11th one is given there. There are two spheres of equal mass made up of iron and wood. So which will have more inertia? Okay, there are two spheres which are made up of, one is wood and another one is iron rod. Okay, so wood sphere will have the less mass than the iron sphere. So then which has more inertia? We know that the inertia is directly proportional to the mass. So it is the iron one is more inertia. So iron one has more inertia there. So now here the option is what there? First option, iron has more inertia. So 11th one is iron. Iron has more inertia. Iron has more inertia. Iron has more inertia. Okay. So Newton's first law of motion is also called as law of inertia. Okay. So Newton's law of inertia. So first one is, so 12th one, Newton's law of inertia. The first law is also known as Newton's law of inertia. Newton's law of inertia, first one. Okay. That is the 12th one then. Now numerical answer type questions are there here. Two bodies A and B have same mass are moving with velocity 2v, v and 2v respectively. Then the ratio of the inertia is So ratio of inertia is the same. No, it does not depend on the velocity of the body. Inertia will be depend only on the mass. So they have same equal inertia there. So ratio of the inertia is same there. So 13th one is 1 is to 1 will get there, 1 only. And you launch forward when car suddenly comes to halt and you will be thrown backward. Okay. So you launch forward when car suddenly comes to halt. Okay. So whenever it is comes to halt there, means it is going to be stopped there. Then you will thrown backward. When your car rapidly accelerates, the dash law of Newton's involved. So first law. So here 14th one is also first law. And 15th one. So 15th one, the behavior of the body undergoes resultant force is given by dash law. That is also first law. Behavior of a body undergoes under zero resultant force, it is first law. So this will be the first law. It is the first law there. Okay. So this is about the synopsis 1. Now in synopsis 2 we have so synopsis 2 it is about explaining about the linear momentum. So now we'll see the linear momentum of the body there. So what is the linear momentum? So linear momentum is nothing but the product of mass and velocity. Linear momentum, synopsis 2. So about the linear momentum. So linear momentum is denoted by the letter P, and it is the product of mass and velocity of an object. Product of mass and velocity of an object. So this linear momentum is measured in SI unit. SI unit of linear momentum P is so kg meter per second. Kg meter per second, and this one here kg meter per second. Now dimensional formula. Dimensional formula of linear momentum is, so this is a kg meter per second means that is m power 1, L power 1, T power minus 1. So that is the dimensional formula of linear momentum. It is a vector quantity. It is a vector quantity. It is a vector quantity. Linear momentum is a vector quantity. And the vector notation, it can be written as here P bar is equals to m into V bar, we can write there. So P bar is equals to m into V bar, we can write there. Okay, this is about the linear momentum. And now we are going to see their next concept, that is change in momentum. Now the change in momentum is nothing but it is denoted by change in momentum. Change in momentum. The change in momentum is denoted by the delta P. It is nothing but the difference in final momentum and initial momentum. Difference in final momentum and initial momentum. So that is P2 minus P1. Delta P is equals to P2 minus P1. So here delta P. So P2 is nothing but what can we write there, m into V, mass of the body and final velocity, and here mass of the body and initial velocity. So delta P can be written as here m, if you take common there, V minus U will be there. It is also can be written as here delta V. So therefore the change in momentum is m into delta V, or delta P is equals to mv minus mu, okay, or m into V minus U. That is the change in momentum. So whenever the body has initial velocity, it is whenever the body is starting from its journey, it has a certain initial velocity will be there. After traveling certain distance, after certain time, it will be get final velocity. So then in that journey, the change in momentum, it is said to be the difference between the final and initial momentum is known as it is the change in momentum. So now the change in momentum same, it has the same units and dimensions as a momentum there. So change in momentum is also has the kg meter per second, and the dimensional formula is m power 1, L power 1, T power minus 2. That is the dimensional formula there. So it is also, the change in momentum is also vector quantity. Okay. So now we'll see the concept based questions there. A set of force, a force or set of force can change the speed of the body, change the direction of the motion of the body, change the shape of the body there, okay, and then all of the above. So answer is what can we write there in concept based questions. So all of the above we can write there. So practice sheet first one. Practice sheet first one. So all of the above, option 4, fourth option. And second one you see here, in which of the following cases the force may not be, in which of the following cases force may not be required to keep. So when a particle is moving in a circular motion, okay. So first option 1 is the right answer. Third one is given here statement. A force is the cause of acceleration of a body. A non-zero net force is referred to as the unbalanced force. Non-zero net force is referred as unbalanced force there. So both are correct there. Option 1. Both are correct. Option 1 we can add here. This one. Third one. Now see the fourth one. Consider the following two statements. Here the two statements are given there. linear momentum of a system of particle is 0, kinetic energy of a system of particle is 0. So it is option B. It is option 4. Okay, option 4 is the right answer. What is the option 4 there? B implies A, but A does not implies B there. Okay, B implies A there because it is a linear momentum, is a vector quantity, energy is a scalar quantity. So then what happens there? Linear momentum may be 0. Okay, suppose the linear momentum, it is moving in opposite direction with the same value, then it will be, it does not have the 0. Okay, then kinetic energy may be 0. So B implies A, but A does not implies B there. Okay, so option 4 is right answer. To reduce the momentum of a given body to half its original value, the mass can be reduced to half, the velocity must be reduced to half, mass can be reduced to half, and reduced to 1/4, velocity is double there, all of the above. So to reduce the momentum of a given body to half of its original value. So if half of its original value means the mass can be reduced to half or velocity can be reduced to half there, then if it is reduced to half, then it will become half of the linear momentum, it will become velocity must be reduced to half. So that also we can consider there, mass can be reduced to 1/4, velocity is doubled. So then also we will get there half only, all the above. So fifth one is all the above will come there. So that is the fourth option. Option fourth one is right there. And the sixth one is, a body is at rest cannot have. A body is at rest cannot have. It is the rest there means velocity will be 0 there. It does not have the kinetic energy and both. So option velocity is 0 means both the momentum and the both will be 0 there. Okay, option 3 there. The product of mass and velocity of a body is called their linear momentum. So seventh one is option 2. Seventh one is option 2 there. Eighth one you see there here. The linear momentum of a body is denoted by the letter P there. Option 2. So it is denoted by the letter P there. Ninth one you see here. Ninth one is the momentum of a body is dash quantity. It is a vector quantity. No, this is a vector quantity. So option A. Option first. So first option is right there. And 10th one here. The quantity of motion of a body is directly proportional to its. So mass and velocity. So both will come there. It is directly proportional to mass and it is also directly proportional to. So this is about the concept based questions. Now exercise problems you see there. What will be the momentum of a body if mass is 10 kg moving with velocity 10 meter per second there. Okay. So 10 kg and 10 meter per second there. Okay. So here exercise problems. Exercise problem. So 2 here, and first solution you see here. First solution, mass is given here, m is equals to 10 kg, and velocity is given also, it is 10 meter per second. Then so momentum they are asking there. Momentum is nothing but what there, m is equals to m, v, p is equals to m into v. This is a 10 into 10, so that is equals to 100 kg meter per second. So this is the momentum there. So now second one we can add there. What will be the momentum of the body of the mass 15 kg moving with velocity 5? Okay. Then 15 kg, same formula. So same formula. Here mass is given here 15 kg and velocity is given here 5 kg, 5 meter per second. 5 meter per second there. Now momentum. So momentum is equal to what there? So P is equal to m into v, we can write here. There is a 15 into 5. It is a 75 kg meter per second. So therefore P is equals to 75 kg meter per second. 75 kg meter per second. So now third one is either if mass of a body, m is the mass of the body and v is the velocity of the body, then momentum of P, the body is given by, momentum of the body is given by. Option 2 now here. Third one is, so P is equals to m into v. This is the answer there. M into v. That is the answer. Third one is that one. Now, so fourth one, fourth solution. See the fourth solution there. A body has mass 2 kg having the kinetic energy 4 joules, their linear momentum. Okay. A body has mass of 4 kg. So mass is 4 kg means it is m is equal to 4 kg. So then so kinetic energy, sorry, the kinetic energy is given there 4 joules. Kinetic energy is equals to 4 joules is given there. Kinetic energy is 4 joules. Then linear momentum is equal to how much there? So we have the kinetic energy relation, no? Kinetic energy relation. Mass of 2 kg. Mass is given here 2 kg. Mass is 2 kg. So the kinetic energy is formula relation between kinetic energy and linear momentum. Okay. So K is equals to P square by 2m, no? K is equals to P square by 2m. So here now P is equals to what can we write this? Square root of, you bring this side 2m into Ke will come there. So send this cross multiplication, 2m into Ke will be there, P square will be there. If you send the root that side, it will become square root of 2m into K we can write there. Now here 2 into m value how much there? 2. And here K value how much there? 4 there, okay. So then it is 4 kg meter per second. 4 kg meter per second will be there. This is a linear momentum. Okay. That is the linear momentum. Is it clear? So now two bodies of masses m1 and m2 having equal momentum, their kinetic energies are in the ratio. Okay. So equal momentum, no, here it is fifth one, you see there, fifth solution. So m1 is m1 comma m2 masses, and p1 is equals to p2, that is equals to p if you write there. So ratio of kinetic energy formula is what there. So p square by 2m, p square by 2m. Now from this kinetic energy is inversely proportional to mass. So now K1 by K2 can be written as here M2 by M1. So that is the answer there. Sixth one you see there. The kinetic energy of a body of mass 1 kg and linear momentum is 2 is kinetic energy of a body there. Mass of 1 kg. So same formula. Same this formula only here. Kinetic energy of a body. Kinetic energy of body is what there? Mass of body. So linear momentum is given there. So P is equals to 2 Newton second is given there, and mass is equals to 1 is given there. So P square is nothing but P square by 2m, no? P square by 2m. This will be 4 divided by 2 into 1. It will become 2. So therefore the kinetic energy is 2 joules. Kinetic energy is equals to 2 joules. Kinetic energy will be 2 joules. Okay. So next up. So seventh solution is here. What will be the momentum of the body of mass 20 gram moving with velocity 5 centimeter per second? Okay. So mass of 50 grams, mass of 20 grams, convert this into mass of 20 grams, and here they are given there, all the options are given there gram per centimeter square only. So here V is equals to 50 centimeter per second, 50 centimeter, this is a centimeter per second, okay. So then momentum is equal, what will happen there? Momentum, here P is equals to m into V, so this is a 20 into 5 there, 20 into 5, gram centimeter per second. So how much it will become there? It is a 1000. 20 grams, 20 into, this is a 5 centimeter, not 50 there, 5 centimeter. So it will become 100 gram centimeter per second. So here linear momentum is 100 gram per second will be there. Okay, that is the answer. See there now. Eighth question, eighth solution. Mass of body. So linear momentum they are asking there, linear momentum. If u and v are the initial and final velocities of a body, m is mass, initial momentum is given by. So initial momentum will be mu. So if u is initial velocity, initial velocity, and v is the final velocity, and the mass, m is the mass there. Then initial momentum here p is equals to pi is equals to m into u, we can add that. This is the initial momentum. So ninth one you see here, ninth one. So in the above question, final momentum. So final momentum, what can we write there here? So pf will be the final momentum, m into v we can add there. P is equals to m into v will be the final momentum. And 10th one you see here in the above question, the momentum is given by change in momentum. So 10th one is asking there change in momentum. Change in momentum is what, that delta p, that is equals to p final minus p initial. So we can write here mv minus mu. So therefore the change in momentum delta p is equals to m into v minus u, we can add there. Okay, change in momentum m into